Here goes a video on solving with factoring. So before we get to the solving part, what I want to do is I want to just recap on a few different ways that we've factored before. So, first way we have is a sum of cubes. So if you remember from our last video, this is just a small set and a large set. Same sign, opposite sign, plus sign. The cube root of x cubed is x. Cube root of 64 is 4. Square your x, you get x squared. Square the 4, you get 16. And 4 times x is 4x. And that'll take care of the first one. The second one, the first thing you should notice is you need to factor out a 2 here first, leaving you with x cubed minus 27. And then again, you see that that's the difference of 2 cubes. So we have 2, our small set, and our larger set. We have a minus plus plus. So we're going to have an x, 3, x squared, 3x, and 9. And the last one in the first row is grouping, where we're going to group the first 2 and last 2 together. We're going to take out an x squared, leaving us with an x plus 2. We're going to take out a negative 16, leaving us with an x plus 2. The insides are the same, so we have x squared minus 16, and we have x plus 2. But x squared minus 16 is a difference of 2 squares, so we have an x plus 4, an x minus 4, and an x plus 2. Again, all three of those are just review from the last video. So now we're going to go on to the next row. This first example really is not anything new. It's a throwback to what multiplies to 8 and adds to 6. The only difference is you have an x to the 4th x squared and then no variable. So this is x squared plus 4 and x squared plus 2. As you see, it's the exact same. 4 times 2 is 8. 2x squared and 4x squared is going to give you your 6x squared. And then x squared times x squared is x to the 4th. So it still multiplies. It's just, instead of doing x plus 4 and x plus 2, it's x plus 4, or x squared plus 4 and x squared plus 2. Next example is an example of the difference of 2 squares. So we're going to have our 2x squared minus 3 and 2x squared plus 3. There is nothing else you can do from here because there's no more difference of 2 squares. So that's just one step. And this last example, again, what multiplies to a negative 18 but adds to a negative 7, that's an x squared minus 9 and an x squared plus 2. But as you see, the x squared minus 9 is the difference of 2 squares. So we have x plus 3, x minus 3, and x squared plus 2. So this first section is all review. You should know how to do every one of those problems. The only difference is now we're going to start solving. So when you solve, what you're doing is you're actually finding the value of x that makes this a true statement. So for this first example, we have to factor, and we're going to set all of our terms equal to 0. So what multiplies to a negative 8, but that adds to a negative 2? And that would be x squared minus 4 and x squared plus 2. Now both of these are equal to 0. This can factor down even more. So we have x plus 2, x minus 2, and x squared plus 2. And all three of those terms are equal to 0. So I'm sure you remember that the first two, x just equals a negative 2 and a 2 because you set them equal to 0. But do you remember what to do when you have x squared plus 2 equal to 0? So we'll make a little side note here. X squared plus 2 equals 0. X squared equals a negative 2. So x is equal to plus or minus the square root of a negative 2 is I root 2. So your last two terms are plus or minus I root 2. So the factoring is a little bit more challenging in this chapter, and as you can imagine, so will the solving. So your next example is the difference of 2 squares to start. So we have our two terms and our plus and our minus. And this is going to be equal to 0. The square root of 16x to the fourth is 4x squared and 4x squared. The square root of 81 is 9. And then you can see we have a difference of two squares again. And we also have an 4x squared plus 9. So what I would like you to do is pause the video from here and see if you can finish this problem. I started it for you. You see if you can finish it. So, did you get it correct? The first thing you had to do was the difference of two squares of the second term. Now these two are easy. You just subtract your 3 and divide by 2, add your 3 and divide by 2. So we have a negative 3 halves and a positive 3 halves. But for this guy, remember, here's another side note for you. 4x squared plus 9 equals 0. So 4x squared is equal to a negative 9. So x squared is equal to a negative 9 fourths. And then you square root both sides, and the square root of 9 fourths is 3 halves. But since we have the I, or the negative, we have an I, so it's plus or minus 3i over 2. All right? So this last one, this is a fun one, because there's a lot of steps involved. First thing you have to do is factor out a GCF of 2x, which is going to leave us with x cubed plus 5x squared minus 9x minus 45. And as you can see, we have 4 terms, so we can just put new parentheses right there in between. So we have a grouping. Remember, do not forget about your 2x. He's still there. So you're going to factor out your GCF of this term, which is x squared, leaving you with an x plus 5. And then we're going to have our negative 9, which is going to leave us with an x plus 5. So, our final factored, well, first we have to group these guys. So we have x squared minus 9, which we see is difference of two squares. So our final factored answer for this problem is 2x times x plus 3 times x minus 3 times x plus 5. So if we set every single one of those terms equal to 0, 2x equals 0, so x equals 0. X plus 3 equals 0, so x equals negative 3. X minus 3 equals 0, so x equals 3. And x plus 5 equals 0, so x equals a negative 5. And this might seem like a coincidence, but it's not. Look, x to the fourth power. Remember, that's how many possible solutions you can have. So, as soon as you saw that this was x to the fourth power in the beginning, you should have realized that you could have 4 answers, same like the ones above. We had 4 answers for this one, 4 answers for that one, because a plus or minus counts as 2 answers. All right, that's solving for you. Again, as you see, factoring is very important for this semester, so make sure you've got all of your factoring down. This is Longo, and I'm out. See you, bye.